one they do give us the picture, so that eliminates one aspect. Also, notice that they do give us an equation. Okay. However, like I said, anytime that it asks you something about an angle, our first thought should be I'm going to have to use some sort of trig function. And notice here that they give us our bottom leg, and then they give us information about the distance that the rocket is launching, which would be the opposite leg. So notice we have opposite and adjacent, which is why we end up using tangent. So they might not always give you that equation. However, we know enough right triangle trig that we should be able to figure out, like, okay, if these are the two sides that I have information about, which trig function should I use? Okay. So let's go ahead and figure out what other given information do we have here. We do, so that's going to be our S, which is like the distance. Do they give us anything else? Okay, they give us this bottom number. So looking at my equation, my two variables are going to be theta and S, and then also we're talking about taking the derivatives with respect to what? Time, right? And so do they give us anything about time? 10 seconds. So we know that our T is 10. Okay. And what is it asking us to frame? So what would that be? So remember that it's the derivative of my theta because that's what we're trying to find the rate of change of, and we're taking it with respect to time. Agreed? Now, notice that they didn't give us a ton of actual numbers here. However, as someone pointed out, they did give us an equation with the S, and that's going to be important here in a minute. Okay? So in the last two that we worked yesterday, they actually gave us numbers to plug in for every single thing. Right? This one's going to be slightly different to where they don't give us the numbers, but because they give us that equation, we are going to be able to find all of the needed information. Does that make sense? Okay. But we do have our equation here. What do we need to do with that equation now? So again, what are we looking for? What's our unknown? What are we trying to find? D theta dt. So what do we need to do with our equation? Take the derivative, right? So I've written out my givens and unknowns. I have an equation. They gave us the equation, so we didn't have to produce an equation that related to things. So basically, just now we need to take our derivative. So what is the derivative of tangent? Okay. And remember that we're taking the derivative with respect to t. So what do we have to multiply by? Okay. Now, be careful on the right side. Okay. Because there is a fraction bar there. However, do we have to use the closure rule? No, because I do not have variables in the denominator. Yes? So 1 over 2,000 is just a constant, so we don't have to worry about that. So what is the derivative of s? No, s is just s. What's the derivative of just a variable? Just 1, right? But then again, we're taking the derivative with respect to t, so what are we going to have to multiply by? Yes. dt. Are we all okay with that? are looking for d theta dt, so we don't have to plug something into there. 1 over 2,000 is a constant, so we're all right there. However, in order to be able to solve for d theta, I also need to have ds dt, and I need to have a theta to plug in there. And this is the part where I told you they did not give us just a ton of like numbers to plug in, like some of the ones we dealt with yesterday. Okay. However, they did give us this equation, yes? So if I know that s equals 50t squared, can I find ds dt? Yeah, I have an equation that is s equals stuff with t's in it. I can easily take the derivative of that. What is my derivative of that going to be? Yeah. We're all okay with that. Yes? But at the end of the day, what did we say that we're wanting to plug in for our t? 10. So what do I end up with for ds dt? 1,000. So 1 down, right? So this just becomes 1 over 2,000 times 1,000. So 1 down. Yes? And again, we said that we are solving for the d theta dt. So we don't have to worry about finding that one because that's what we're trying to get to at the end. However, what do we need to know in order to be able to plug into our secant or find our secant? Okay, so again, they don't give us a theta. However, do they give us an equation that has a theta in it at the beginning? Yeah, tangent of theta equals s over 2,000. Agreed? So what do I need to know in order to be able to find my theta? S, okay? Again, they didn't give us an s, but we have a t value. Agreed? So, and I know that my t is what? 10. So that means that s has to be what when t is 10? So 10 squared times 50 would be what? 5,000? Do we agree? Yeah? Okay. So then I can use that piece of information to find this. We're all with me. Like I said, there's a lot of moving parts on this one. None of it's necessarily like super difficult. It's just having to use the information that they gave us. So I have tangent of theta equals 5,000 divided by 2,000. So we end up with 5/2. Okay, and then how would I solve for theta? Inverse what? Tangent. So I have tangent inverse of 5/2. Agreed? That's not going to be a very pretty number, and that's okay. However, I would like hold off on getting a decimal approximation until we kind of plug everything in. Does that make sense? Just because otherwise we'll get a larger rounding error. You with me? Okay. So then my last step would be to solve for d theta dt. So this is 1/2, agreed? And I'm going to be dividing by secant squared of theta. Yes? So then I'm just plugging all of this in. Okay? So I would plug in 1/2 divided by secant of tangent inverse of 5/2. And then you're going to square that denominator. You're going to plug all of that into your calculator. There's going to be lots of parentheses though, so make sure that you end your parentheses after your tangent inverse. You also need to end your parentheses after the secant, so you can square that number. You don't want to square the inside, you want to square the whole secant part. get into our calculation? So what is this technically if we wanted to simplify our lives a little bit? If I have 1 over secant, that's the same thing as just having cosine, right? So I could also write this as 1/2 times cosine squared. Makes it a little bit easier to plug into your calculator instead of having to type in 1 divided by 1 divided by cosine. And what do we get? They don't give us a degree measure here, so we're gonna assume that we are in radians, unless they tell us otherwise. Do we get anything? Maybe? Okay. What do we get? Yeah, so it's 2 over 29 or 0.069. Yeah. And then what's your unit here? What is our unit of our theta? Well, our unit of our bottom is in seconds. But what's per second? Is our theta in feet? What did I say we were in? Radians. So it would be radians per second. Because it's talking about an angle. So it's talking about how quickly is the angle rising or lowering depending on what it's asking for. So your unit is either going to be in radians per second or degrees per second. Does that make sense? Questions about any of this stuff? Like I said, we had to go out and search a little bit more for some of our information this time, but we were still able to find everything that we needed. The other big example of where we will see these types of problems is going to be with ladders. Lots of ladders. We'll see what we have to do. So it says a bag is tied to the top of a 5-meter ladder resting against a vertical wall. Suppose the ladder begins sliding down the wall in such a way that the foot of the ladder is moving away from the wall. How fast is the bag descending? At the instant the foot of the ladder is 4 meters from the wall and the foot is moving away at a rate of 2 meters per second. Very wordy. So what we say is usually going to be helpful to do. Draw a picture. Okay, so we have a vertical wall, as you do, okay, and then our ladder is resting on the wall. So what is our ladder going to end up being? Yeah, it's going to, well, specifically the what of the triangle? The hypotenuse of our triangle. So like this is our little ladder. It's a great ladder, I know. But for the purposes of the drawing, we understand what it is. Okay. which, let's label some of our picture. What is going to be 5 meters? The ladder, which is our hypotenuse. Alright. How fast is the bag descending at the instant the foot of the ladder is 4 meters from the wall? So 4 is my bottom. Okay. So my height is going to be what? Y. Okay. Geometry, what? Okay. And let's label it. Go ahead and label our bottom X just because it's our horizontal. Do we know anything else? There is, okay. And that's what's making it slide because it's heavy. Does it tell us anything else at the end there? We're asking for how fast the bag is descending, okay, and it gives us how fast it's moving away. So both of those are rates. Agreed? We have to decide which one is which. Does that make sense?
So is the rate of moving up the ladder top of
We're assuming because it's attached to the ladder, they're moving together. So what is it asking us to find? How fast the bag and the ladder are descending. So how fast it's going down. Okay, so that means that we are looking for dy dt, which means that the way how fast it's moving out would be what? dx dt. So that is 2. So this one they don't give us an equation, but do we have an equation? What? So we need to create an equation that relates our variables together. So our x, y, and our 5. What? Yeah. So notice that x squared plus y squared has to equal I squared. Yes? 25. Sorry. Yes? So you don't want to plug stuff in too early because notice that if I go ahead and plug in x, right, when I take the derivative of that, I don't have a dx dt. So like I still need to take the derivative with my variables in there. That way then I can still plug in and solve. Does that make sense? The only thing that it makes sense for when we take the derivative, right, for it to be 0, is the height of my ladder changing? No. Like, my height of my ladder is not, like, condensing or something like that. So it makes sense that when I take the derivative of 25, that's going to be 0 because that part's not changing. Does that make sense? Like, that's why that part is a constant, and when I take the derivative of a constant, it's going to be 0. But it makes sense for that to be 0. My other two are getting shorter or longer, so we do need to know how they're changing. Are y'all with me? So then, what is the derivative of this? 2x. Nope. What am I taking the derivative with respect to? T. So dx dt. Then plus 2y dy dt equals 0. Be careful there, because what do we think a common mistake probably is? Not put, well, some people might put 1, or they would just put 25 again, right? Like, they would just forget to take the derivative of that right side. Okay? So again, we are solving for dy dt. Do we have all of our other information? Yeah, they didn't technically give us the y, right? But again, with the information that they gave us, we were able to find it. So we have all of our needed information. So we have 2 times, this is 4 times 2 plus 2 times 3 times dy dt equals 0. So we get 16. So we end up with dy dt equals negative 16 over 6, which is what? Yeah, I just meant like, what's the decimal approximation of it? 6, 6, 7. And what's our unit here? Meters per second. And again, we always want to make sure that our answer makes sense. Does it make sense that our y is getting smaller? So it's negative. Usually with these you will, just, unless it's like it makes more sense for it to be a fraction, just because like most of these you're dealing with distances, and so it makes sense, you know what I mean, to talk about like 2.6 meters versus like negative 8 half, you know what I mean, like 8 thirds or something, like it's just hard to talk about it. They're not going to count it wrong, and I wouldn't count it wrong. That usually makes more sense to have it as a decimal here. But does it make sense for us to have a negative value? Yeah, because our y is getting smaller, which is the same reason why our dx dt was positive, because if this is getting smaller, my x is getting larger. Does that make sense? Question?
So since it asks specifically for how fast is the bag descending, do we need to like take the absolute value for a final answer? Or we just leave it?
I would leave it like that. Most of the time, especially on the AP test, if you didn't write the negative part, they would want you to say down the wall. So like, you could get away with taking the absolute value as long as you said like 2.67 meters per second down the wall or descending.
If I wrote out like the whole like it is
Descending at, yes, then that would be okay. If you just wrote an answer and didn't put it in like back in full context, you would want to keep the negative, because they want to know that you know it is going down, basically. So either way. Other questions? How's it going? Alright, we have one more example, I believe. So this says find the rate of change of the distance between the origin and the moving point on the graph of y equals x squared plus 1 if dx dt equals 2 centimeters per second. So what do we want to do? So we already have a picture, yeah? Yes, no, maybe. So what might it be helpful for us to do? We have a picture, right? I have a parabola. Yes, so write out our givens and unknowns. So what do they give us? Okay. Well, that's nice. It's already nice and labeled for us. We don't even have to figure it out. They give us the equation. Okay. So then what is our unknown? What are they asking us to find here? Yes. So what would be a good variable for our distance? D. Okay, so what are they asking for then? Yes, we'll get to that. But like if they're asking us for the rate of change of the distance, how would I represent that? dd. That's fine. dt. Right? Is going to be my unknown. You can pick whatever variable you want. So like if that makes you uncomfortable, like you don't have to put it that way. Okay. Now, if they give us, some equations, do I want to take the derivative of that equation? Why not? No. So like I could still have to take the derivative of that. If they asked me a different question, if it asked for like the rate at which y is changing, something like that, then that would be dy dt, yes? But they don't ask for that. What do they ask for? The rate of change of the distance. So does that equation give me distance? No, and I'm not taking the derivative of distance. So I need an equation that when I take the derivative, I get dd dt. Does that make sense? So what are we going to be using? The distance. So what is our distance formula? Forgot something. It doesn't. It doesn't matter if you have it x1 minus x2 or x2 minus x1. You get the same thing. Okay. So we got to do a little bit of processing here. I have a nice pretty picture. Okay. They tell us that my point is moving. Okay. So I'm going to pick an arbitrary point. Even though I'm plotting it there, it's just for the purposes of me drawing a picture. Does that make sense? Because it could technically be anywhere along my line. You with me? So, what does x2 minus x1 represent? The change in x. Are we all with me? And then y2 minus y1 is the change in y. You know with me? So, yeah, we do. So, what would technically, at any point along there, my change in x is really just going to be whatever x value that is. Right? Because it's the change from the origin. Yes? Well, okay. Or like you were saying, if I use the origin, right, as my second point, then it would just be x, I don't know what it is, minus 0. So I just end up with x. Does that make sense? Are we all with me? Same thing here. Again, if I'm using my point as the origin, I'm just going to end up with a y there. Agreed? Yes? So far, so good? And that's going to make our lives easier as well. The only hard part is notice that d equals the square root of, this is just going to become x squared. That's nice. However, do I want to put in a y there? Not really. 'Cause they don't give us any information about dy dt, so if I took the derivative, I wouldn't have anything to plug in for that. So what we want to do instead is plug in the information that they give us for y. So x squared plus 1 squared. We're okay with how I got the setup. So like again, here I am simplifying this just to be x squared plus y squared. If I use any point along my curve, and let's say I use my second point to be my origin, if I subtract x and y and I subtract 0, 0, I'm just going to get x and y. So I just end up with x squared. It's the distance from the origin. Because again, like I said it so that you'd be okay to like think about it. But again, like if you're going along the curve, your change in that is always just going to be x and y. Like that's just what it is. So let's go ahead and simplify this guy a little bit. What is x squared plus 1 squared? Plus 1, right? 1 have fun, give me 1. So then what do we want to do with that? What's our goal? Yeah, we can combine like terms. And our goal is to take the derivative, so I'm going to rewrite it as a 1/2, so I get plus 3x squared plus 1 to the 1/2 power. We're okay with that. Again, I want to use my exponent rule. What else are we going to have to use? My exponent rule and my chain rule. Okay. I'm taking my derivative. So dd dt. And I'm bringing down my 1/2. I subtract 1, I now have a negative 1/2. But what do we also always have to multiply by? Not the inside. The derivative of the inside. Okay? What is the derivative of the inside there? Okay. And then, what else do I have to multiply by? Because what are we technically taking the derivative with respect to? T. So I have to technically multiply by the other inside, which would be the dx dt. Which, yes, we know that this is 2. So notice that my 2 and my 1/2 are going to reduce. So that's nice. And also, do they give us any more information there? Do they give us anything else to plug in, like a specific point that they're wanting it at? No. So they're just wanting the equation at which the distance is changing. So this would just become my 4x cubed plus 6x is on top. And this becomes the square root of x to the 4th plus 3x squared plus 1. And if they then said add a specific x value, you can plug that in. In this case, they don't, so I'm just going to leave it like that is the rate at which the distance is changing. You would need to know a specific x value to be able to get like an actual number there. Question? questions on that. Again, like I said, the biggest thing with like these types of problems, none of the steps are necessarily hard. It's kind of just breaking down, okay, what do I already have? What do I need to find in order to have all the information that we need to plug it in? And kind of the hard part is that like, each problem is going to be a little bit different. It's not like obviously like I gave you steps yesterday. Like the steps are kind of the same, but like on this one we had to use the distance formula. On the other one we had to use a trig equation and plug some other stuff in. So like you just kind of have to dissect each individual problem to figure out what do you need and what's the equation